What's up, everybody, and welcome back to lesson 6 of grade 11 physics. Now, in the previous video, we talked about uniform acceleration, and I told you, if you remember, to memorize all the 4 equations that we had for uniform acceleration. Now, we have already dealt with practice 1C. We'll be reaching today sample problem and practice problem 1D. Okay, without further ado, let's delve into the topic. Now, we have sample problem 1. It's already solved, but let me solve it for you again. It says, a plane starting at rest. Okay, remember what we said. We had some notes when we were dealing with velocity and acceleration. If it says at rest, it means that V initial was equal to 0. Okay, now we're going to say V initial is equal to 0 meter per second. Okay, that is the first given. Okay, at one end of a runway undergoes a uniform acceleration of 4.8 meter per second squared. Okay, acceleration is equal to what? 4.8 meter per second squared. For about how much? For about how long, sorry? For about 15 seconds. Okay. What is the speed at takeoff? Okay. So if you ask yourself, how do you know which speed is it asking? Is it asking for final velocity or average velocity? It's not asking for average velocity. Why? Because we already have initial velocity. And if we have initial velocity, then we need V final. Careful. Okay, so V final is equal to what? Okay, that is the first part. Let's deal with the first part, then we're going to come back to the second part, okay, which says how long must the runway be for the plane to be able to take off. Okay, now guys, look. We need to find V final. First of all, let's take a good look at the givens. We have V initial, we have acceleration, we have delta t, and we have V final. Okay? Now, we need something to be able to know which equation to use. We need to figure out what physical quantity that we have studied until now is not being mentioned. So we have V final, V initial, acceleration, and delta t. Please think about it. What physical quantity is not mentioned here? Delta x is not mentioned. Now, go back to the 4 equations of uniform acceleration and see in which equation you don't have displacement. Okay? Now, we have what? We have V final, which is equal to V initial plus A delta t. Okay, now V final is equal to what? It is equal to V initial, which is equal to 0 meter per second plus 4.8 meter per second squared times 15. V final is equal to what? It is equal to 72 meter per second. That is the first part. Okay, we found V final. The second part of the question, it says how long must the runway be for the airplane to be able to take off? Okay, so it says how long must the runway be? So we need what? We need delta x. Okay, this time it's talking about delta x. So delta x is equal to what? Okay, delta x is equal to what? So we have V final this time, which is equal to 72 meter per second. Now guys, we have delta x, which is equal to 1 over 2 in a bracket, V final plus V initial, multiplied by delta t. And then we have delta x, which is equal to V initial multiplied by delta t plus 1 over 2 A delta t squared. Okay, so which one you're going to use? Okay, it doesn't matter which one you use. Why? Because whichever you use, you have all the givens. For example, if you use this equation, let's say delta x is equal to 1 over 2, okay, v initial plus v final multiplied by delta t. We have v initial, we have v final, and we have delta t. So we don't have any problem finding displacement. Let's use the other one. So delta x is equal to v initial multiplied by delta t plus 1 over 2 a delta t squared. We have v initial, we have delta t, we have acceleration, and we have delta t too. So it doesn't matter which one you use. Choose the one that is the easiest. So I'm going to use this one. Okay, it doesn't matter if you use the other one too. You're still gonna get the same result. Delta x is equal to what? Is equal to 1 over 2. V initial was equal to 0 plus V final, which is equal to 72. And then delta t, which is equal to 15 seconds. Delta x is equal to what? It is equal to 540 meters. Okay? When you're able to realize or figure out which physical quantity is not mentioned, then you know what equation to use. Okay? The following questions, it's exactly as the same as the sample problem we used. Okay, we solved, sorry. And you're gonna see, it says a car with an initial speed. You don't have to think about it. It says initial speed. So V initial is equal to 23.7 kilometer per hour. Okay, now accelerate at a uniform rate of 0.92 meter per second squared. So acceleration is equal to what? It is equal to 0.92 meter per second squared. For how much? For 3.6 seconds. For 3.6 seconds. Find the final speed. So V final is equal to what? We should first find V final. And then it says what? The displacement of the car during this time. So delta x is equal to what? Okay, now let's find V final. The same equation we used just now. Okay, so we're going to say V final is equal to V initial plus a delta t. V final is equal to 23.7 plus a, which is equal to what? Is equal to 0.92 times delta t, which is equal to what? 3.6 seconds. Now guys, is this correct? No. Why? Think about it. Because this is kilometer per hour. You cannot use that in this equation. Why? Because you have meter per second and you have second here. The units are not consistent. Careful. طبعا انت مشاكل ليرة كيلومتر لسر ساعات دراوة باشا ليرة متر لسر كمان هي ليرة متر لسر كمان هي كاتنا توانين يكسر بيسوسي بوينت حود لإيكويجنا كده ابني سرتا بيسي بيقورن بوتي بيقورن بو متر لسر سكة عفري باشا V initial لكسانا ب 23.7 how can we change that to meter per second? Divide this by 3.6, okay? 3.6 and we have 6.53. So V initial is equal to 6.53 meter per second. باشا كاتاوي رجلك هنا أو بكل كمان نايلة باشا ضلين سي 6.58 meter per second. Now this is the correct way. Okay, now 6.58 plus 0.92 multiplied by 3.6. We have 9.81. So V final is equal to 9.89 meter per second. Okay, this is V final. The second part of the question says what? Says delta x is equal to what? Okay, Now guys, I told you it doesn't matter which equation you use since we have all the givens, okay? Use the easiest one. Delta x is equal to what? It is equal to 1 over 2 v initial plus v final multiplied by delta t. Delta x is equal to what? It is equal to 1 over 2 v initial is equal to what? It is equal to 6.58 plus v final is equal to 9.89, and then delta t is equal to 3.6. Okay, delta x is equal to what? Let's find this. So 3.6 divided by 2, because 3.6 multiplied by 1 over 2 becomes 3.6 divided by 2. So we have 1.8. Multiply this by what? By 6.58 plus 9.89. Okay, we have 29.6. So delta x is equal to what? It is equal to 29.6 meter. Okay, this is delta x. Okay, now we have question 2. Let me erase this. Question 2, it says what? It says an automobile with an initial speed of 4.3 meter per second. It already says 4.3 meter per second. So V initial is equal to 4.3 meter per second. Okay, accelerates, so we know. Next, we have acceleration. Accelerates uniformly at the rate of 3 meter per second. So acceleration is equal to what? 3 meter per second squared. Okay, find the final speed. It already tells us to find V final. So V final is equal to what? And the displacement. So delta x is equal to what? If we know that delta t is equal to 5 seconds. 5 seconds, okay? Let me use a different color here. Okay, let me use this. Okay, we're going to use the same equation we used before. We're going to say V final is equal to V initial plus A delta t. Okay, we have V initial, we have acceleration, and we have delta t. Just plug them in, and you're going to find V final. V final is equal to V initial is equal to 4.3 plus acceleration is equal to 3, and then delta t is equal to 5 seconds. 3 times 5 is 15. 15 plus 4.3, we have 19.3 meter per second. That is V final. Let's find delta x. Remember, I told you it doesn't matter which equation you use, because we have all the givens for both of them. Okay, we're going to say, let me use a different color here too. So delta x is equal to 1 over 2 V initial plus V final multiplied by delta t. Delta x is equal to what? It is equal to 1 over 2. V initial is equal to what? It is equal to 4.3 plus V final is equal to 19.3, and then delta t is equal to what? It is equal to 5 seconds. Let's calculate that. So 5 divided by 2. Why divided? Because 5 multiplied by 1 over 2 becomes 5 divided by 2. We have 2.5 outside the parenthesis. Multiplied by what? Multiplied by 4.3 plus 19.3. Okay, we have 59. So delta x is equal to what? It is equal to 59 meters. That is the displacement. Now guys, we have question 3 and question 4. They're exactly the same. V final is equal to V initial plus A delta t, and then the same thing for the other one. Okay, please solve them. And if you face any difficulties, please comment below and I'll be happy to help you. We reach sample problem 1E. Let's read the question. It says, a woman pushing a stroller starts from rest. Remember, starts from rest means what? Means V initial is equal to 0 meter per second. Okay? Uniformly accelerating, so acceleration is equal to 0.5 meter per second squared. Okay? What is the velocity of the stroller? We have V initial because we know it starts from rest. It says what is the velocity of the stroller? So we know it is asking for V final. So V final is equal to what? After the stroller has traveled 4.79 meters, so delta x is equal to 4.75 meters. Okay? Now guys, ليرة كام equation بكاردين ما قرروا سر equation كان استبنوسا لسفرك وبزانا كام equation بكاردين عشان بزانا equation كانت لبر بعد ما شايش بك V initial من هي acceleration إيش من هي V final إيش من هي delta x إيش من هي لو همو physical quantity هنا كامي باز نكراوه تمشايك كامان delta t. Delta t is not mentioned, guys. So which equation are we going to use? We're going to use an equation that doesn't have delta t. We're going to say V final squared is equal to V final squared is equal to V initial squared plus 2a delta x. Okay, let's solve this. We're going to say what? We're going to say V final squared is equal to V initial squared, which is equal to 0, so 0 squared, plus 2 times acceleration is equal to what? It is equal to 0.5. So 0.5 times delta x, which is equal to 4.75. V final squared is equal to what? It is equal to 4.75. Is this the result? No, careful. We have V final squared. Whenever you have squared, okay, with an unknown, remove that squared. Okay, so we're going to say V final is equal to what? When you remove the square, make a square root, write a square root in the other side. So we're going to say 4.75. Let's take the square root of this. So we have 4.75. We have 2.17. So V final is equal to what? It is equal to 2.17 meter per second squared. Meter per second, sorry, it's velocity. Okay, that's it. That is the equation we use. Okay. Question 1 from sample problem from practice 1E. It says find the velocity after the stroller is 6.32. So it's the same equation. We're going to say V final squared is equal to what? 0 squared plus 2 times, we have acceleration is equal to 0.5 times delta x, which is equal to 6.32. V final is equal to 6.32. V final squared, V final then is equal to square root of 6.32. Okay, let's take square root of that. I think it's 2.51 if I'm not mistaken. So 6.32. Yeah, 2.51. So V final is equal to 2.51 meter per second. Guys, it says sample problem 1E, just change delta x. Okay, use the same equation, just change the delta x. Okay. A car traveling initially. المشاكل اللي رسالة initially كاتا يكسر دزاني. This is V initial. Okay, V initial is equal to what? It is equal to 7 meter per second. Accelerates uniformly. So acceleration is equal to what? 0.8 meter per second squared. Okay, for a distance of 245 meters. So delta x is equal to what? Is equal to 245 meters. The velocity, okay, it says find A, the velocity of the car at the end of the acceleration. So V final is equal to what? B, it says the velocity after it accelerates for 125. So V final is equal to what? If delta x this time is not 245, but 125 meters. This time it says C. This time it says find V final is equal to what? If this time delta x is equal to 67. Okay, now let's find that. Okay, we're gonna say V final. Again, ask yourself, what is not mentioned here? Throughout the question, there is no mention of delta t. So we're gonna use which equation? We're gonna say V final squared is equal to V initial squared plus 2a delta x. V final is equal to 7 squared plus 2 times acceleration is equal to 0.8 times 245. That is for part A. Okay, it says the velocity of the car at the end of the acceleration. Okay, this is V final squared. So V final squared is equal to what? Let's calculate this. So 7 multiplied by 7 is 49. So 49 plus 2 times 0.8 times 245. We have 441. Don't leave it like that. Remove the square. So V final is equal to square root of 441. Square root of 441. We have 21 meter per second. Okay, this is V final. What about part B? Part B, okay, this was A. Part B, what if delta x is equal to 125, okay, meters? We're going to use the same equation, just change delta x. So V final squared is equal to 7 squared plus 2 times 0.8 times 125. Okay, so 49 again plus 2 times 0.8 times 125. Okay, we have 249. So V final squared is equal to 249 meters. Okay, so take the square root of 249. We have 15.7 meter per second. Okay, part C, it says, what if this time delta x was equal to what? Delta x was equal to 67 meters. Okay, again, V final squared is equal to what? It is equal to 49 plus, and then we have 2 times 0.8 times 67. Okay, we have 156.2. V final is equal to 156.2 square root, of course. Let's take the square root, 156.2. We have V final, which is equal to 12.49 meter per second squared, or 12.5 meter per second. Okay, if you round that up. That was question 2. Now we reach question 3. Okay. Question 3, it says, a car accelerates uniformly in a straight line from rest. Okay, so you know V initial is equal to 0 meter per second. How do you know? Because it says from rest. At the rate of 2.3 meter per second squared, if acceleration was equal to 2.3 meter per second squared, what is the speed of the car after it has traveled 55 meters? So V final is equal to what? If delta x, this is A, if delta x is equal to, let me erase that, A, it says A, it says V final is equal to what? If you know delta x is equal to 55 meters. Okay, let's find V final. So we're going to say V final squared is equal to V initial squared plus 2a delta x. V final squared is equal to what? It is equal to 0 squared plus 2 times 2.3 times 55. Okay, V final is equal to what? V final squared, of course. Let's calculate that. 0 squared is still 0, so 2 times 2.3 times 55. We have 253. Let's take the square root of that, 253. We have 15.9. So V final is equal to square root of 253. And this is equal to 15.9 meter per second. Okay, guys? Now, how long does it take the car to travel 55 meters? Okay, so what is it asking here? B. How long does it take? Whenever you see this expression in a question, it's asking for time. Okay, how long does it take? Okay, so delta t is equal to what? Okay, which equation we're going to use? We're going to use V final, which is equal to V initial plus A delta t. Okay, or you can use the other equation. Okay, let me write this here. Acceleration is equal to delta V divided by delta t. Okay, and then we need to find delta t. So delta t is equal to what? It is equal to delta V divided by acceleration. You can use that equation too. And then delta V is equal to V final minus V initial. Okay, let's use this so you can learn how to rearrange equations too. Okay, so V final is equal to what? It is equal to 15.9. Then V initial is equal to 0, yes, 0 plus 2. Acceleration is equal to 2.3, and then we have to find delta t. Okay. Now take this 0 to the other side. It becomes 15.9 minus 0. This is equal to 2.3 delta t. Now what do you need to find? You need to find delta t. So delta t should be alone. So divide this by 2.3. Divide the other side too by 2.3. 2.3 cancels here. So delta t is equal to what? It is equal to 15.9 minus 0 divided by 2.3. Okay, 15.9 divided by 2.3. We have 6.91 meter per second. Okay, this is, sorry, not seconds, 6.91 seconds. Okay, that is delta t. Okay, or you can use this equation, doesn't matter, it's the same thing. Question 4 is going to be the last question you solve. Question 5 and 6 are going to be for you. Okay, it says, a motorboat accelerates uniformly from a velocity of 6.5 meter per second to the west to a velocity of 1.5 meter per second to the west. Okay, let me remind you something. That we had 4 directions: east, west, north, and south. We could also say that this is positive, this is negative, this is positive, and this is negative. We could also use those expressions too, those directions too. So we have an object, a motorboat, which goes from 6.5 to 1.5. So V initial is equal to, it says west. So west is negative, okay? So it's going to be negative 6.5 meter per second, okay? V final is also to the west, so negative 1.5 meter per second. It says if its acceleration was 2.7 meter per second squared to the east, so acceleration was equal to plus or positive 2.7 meter per second squared. How far did you travel? Whenever you see an expression like this, how far, it means it's asking for delta x. Delta x is equal to what? Okay. Now we're gonna solve this question. We're gonna say v final squared is equal to v initial squared plus 2a delta x. Okay. So how can we solve this? We're gonna say negative 1.5 squared is equal to negative 6.5 squared plus 2 times 2.7 multiplied by delta x. So negative 1.7 squared is going to be 2.25. 6.5, negative 6.5 squared is going to be 42.25. And then plus 2 times, let's see, 2 times 2.7. 2 times 2.7. 2 times 2.7. We have 5.4. So 5.4 delta x. Okay. Take this for t.2 to the other side. Why? Because we need delta x alone. So it's going to be 2.25 minus 42.25, which is equal to 5.4 delta x. Again, we need delta x alone. So we're going to divide this by 5.4. Divide the other side too by 5.4. So delta x remains alone. Delta x is equal to 2.25 minus 42.25 divided by 5.4. Let's calculate this. So 2.25 minus 42.25 divided by 5.4. We have negative delta x is equal to negative 7.4 meters. It's negative. So what else can I say? I can say delta x is equal to 7.4 meters to the west. Okay? This is delta x. And this was question 4. Question 5 and 6 are for you. You're going to use the same equation. Just when you have kilometer per hour divided by 3.6 to change it to meter per second. This is it for today. And if you have any questions, please comment below. I'll be really glad to answer your questions. See you in the next video.